Hello, everyone, and welcome back to week 3 of our online classes. And this week we are going to be covering chapter 16.3, which is the effects of climate change, and 16.4, which is responding to climate change. But before we jump into the chapter, I kind of miss our coronavirus updates that we were doing in class. And possibly some of you guys are missing them too. I did one on our Zoom meeting last Thursday, but not everyone was on, so I'm going to just incorporate it into our lecture. All right, so you guys are familiar with our worldometers.info, the website we've been using to track the overall cases of coronavirus. So you can see here our total number of confirmed cases has reached over 1 million. Again, that number is probably lower than it should be, and we talked about all the different reasons for that in class. Some of those being the availability of test kits. Not everyone that is getting sick is getting tested. A lot of people are recovering without ever having the test performed. We also have seen a lot of younger people or people in general don't always show symptoms or show very mild symptoms that resemble more of a lesser flu or a cold, and so they aren't seeking out those tests as well. And then, of course, we discussed some geopolitical reasons of why there might be some inaccurate information being passed along for those reasons. The total number of deaths worldwide is nearing 70,000 at the moment, and recovered is 260,000, almost 261,000. We're going to scroll down. I just want to point out we are seeing this steep incline in the total number of cases and total number of deaths. And that's because this virus spreads really easily, and that's why we are all under advisement that we stay at home as much as possible. And again, that's to flatten that curve. So hopefully those actions we've taken has reduced the amount of total cases and deaths. Those statistics are hard to predict or understand because we've made those changes. There's no way to go back and not make the changes and then compare, is what we're doing really making an impact or not. And sometimes scientists will kind of get together later after we have more time passes, and we might get some good estimations or some evaluations from some of our experts. I'm going to scroll down to, of course, our list of different countries. At this point, based on the current number of cases that are being reported, the United States has the most amount of cases. Again, these numbers, they are the best that we can do. They are as accurate as possible, but there's some variations on why some of these numbers are the way that they are. For example, China is now listed 6th in line. But guys, back now 2-3 weeks ago, they were already at this case level. So it is kind of hard to believe that their case level has not increased at all. So these numbers might be a little lower than what they should be. And again, that could be because they've run out of test kits, or maybe there's a potential possibility that there's an asymptomatic strand that's mutated, and so people are getting sick, but they don't even know that they're sick. So that could also be a secondary reason. U.S. has, because we are a first world country, we're going to have a lot more kits available. We're going to have the ability to manufacture test kits and test a lot more of our people. We're doing a lot more testing than other countries as precautionary measures, because if we can and we have the test available, if anyone in your family gets sick, we test the whole family as opposed to just the person who is sick. And in some of the other countries, they're only testing the most critical cases, the cases where people are ending up in the hospital on ventilators as far as having and needing respiratory support. Let's take a look at the US a little bit closer. So of course, this is where we're at, and we want to know what exactly is our caseload. So we have over 300,000 currently confirmed cases, and of course, again, I'm going to emphasize those are the cases where people have gotten sick, gone in, gotten the test, and the test has been positive. We have, out of those amount of people that were confirmed, 9,528 people have died at the moment, and only 17,000 have recovered. Remember, this is an illness that doesn't just come and go as quickly as the common cold. People are staying sick for several weeks or a month, or sometimes even longer. So that's why we have such a high number of cases, but not as high a number of recovered cases. So now looking at it state by state, of course, New York is now considered an epicenter. Epicenter meaning that it is a primary source of infection. So there is a high number of cases, and we can see an increasing number of deaths along with that. That's why the government has sent them support. They've even sent military ships, and they're converting cruise liners to act as temporary medical facilities to help aid these areas that are at highest risk. You'll see that we're pretty close to the top of the list. What is that? 7th in the list as far as number of total cases. We have seen several deaths, but we are still under 1,000 deaths for the state of Florida. This, as far as this website lets us zoom in, so just like we do in class, I'm going to hop us over to the Johns Hopkins COVID-19 Resource Center. So let me first zoom out for us so we can take a look at the whole map. I'm going to make that a little bit bigger for us. All right, so you can see that, of course, over in China, they have a high number of cases, but like I said, and we saw on the chart, not as high as we might have expected, especially since this was the point of origin for the virus. We see a severe increase in Europe and, of course, in the United States. We're going to zoom in closer to North America, and specifically the United States. So again, we're seeing that this map matches up with the statistics. We're seeing our most amount of cases are in these highly populated urban areas like New York, Miami, Los Angeles, San Francisco, up in Washington. Let's go ahead and zoom in a little bit closer to Florida. Again, same thing here. Your most amount of cases, the highest reported amount of cases is down in Miami-Dade, Florida, where they have 4,061 cases and 31 confirmed deaths. Again, highly populated urban setting areas. Again, Orlando, Jacksonville, Tampa coming up and close behind as far as caseloads. And then you'll see as you go out into these areas, this area is where we have our Everglades, so a lot of swampland, not a lot of people live there. Up in this area, it's closer to It's much more rural. There's a lot of farm and cow pastures out in this northern Florida, so you can see that the case numbers are a lot lower. Most of us at school live in either Hillsborough or Pinellas County, so we're going to take a look at those real quick. I live in Hillsborough County, and currently we have 528 cases and only 5 deaths. So we're still doing good, but remember, guys, you still want to keep your social distancing. You still want to take any precautions that you possibly can to keep yourself and your family safe, because there is at least a 2-week latency period, which means you can get it and you can be infecting others and not even know you get sick for several days, or even up to, the average is 14, and then up to 27 days is the longest on record, I think, so far. The rest of us live in Pinellas, so you guys have less cases, 347 confirmed cases and only 8 deaths. All right, again, I'm not going over this to panic anyone or make anyone become overly concerned about this. If you are taking all the precautions that we keep hearing about in the news, and you're following proper hand washing, and if you have hand sanitizer, you're using it, keeping commonly touched items, especially between people, possibly your computer, your TV remote, your cell phone, the mouse that goes with your computer, your door handles, doorknobs. Those are the areas you really want to focus cleaning. So if you do have Lysol or Clorox wipes, focus your cleaning on those areas where we share a lot of the common utensils or door handles, doorknobs. That includes, faucets on your handle or in your shower, and also, in your kitchen cabinets. Don't forget about those. So keep up the good work, and stay safe. And we're going to wrap this up and go back to our lecture. All right, so back to good old environmental science, and this is lesson 16.3, the effects of climate change. In 2003, a severe heat wave struck Europe, and it killed 35,000 people. So that just goes to show us that a change in our environment can have devastating effects on the human population. Vocab for this chapter is only 1 vocab word, adding to our book, so go ahead and write this in your workbooks. This is chloral bleaching, which is the death of algae normally fed in reef-building corals. So by the end of this lecture, we should be able to meet the following requirements. We should be able to state ways in which the warming atmosphere affects our ecosystems and organisms. We should be able to explain how climate change is affecting people right now. We also should be able to predict future effects of climate change on people. Before we move on, though, I do want to refer back to last week's lesson, and we talked about the Maldives, and that was basically our case study, and we had a video on it, an optional video that you could have watched as well. And what that covered was, it was a detailed example on the effects of climate change, and that involved increasing flooding, increased severity of storm activity, damage to our coral reefs, and threats to our freshwater supply. The Maldives Island is a direct and vivid example of the impact of global climate change on human life. So the question is, can efforts be made to save the islands, or is this just a natural cycle of land erosion and rebirth? Because guys, we've already talked about the rock cycle, and we've talked about how volcanoes add earth, and then erosion crumbles that back down into boulders, then rocks, and then into smaller sediments like sand, clay, and silt. So I've added this slide in here called the birth of an island. This is supplemental if you want to watch it. I just thought it was pretty cool. Referring back to the Maldives, yes, the Maldives is sinking, but then at the same time, other islands are being formed and created. So if you want to see how that happens, how an underwater volcano can add rock underneath and build up upon itself until it comes into a fully formed island, go ahead and click on that link and watch the Volcano Odyssey, Birth of an Island. If you did or did not watch that video already on the birth of an island, I've added this slide in here as well, just to show you that indeed volcanoes do result in new islands. And a specific example here is Japan's newest island triples in size, they say. The new volcanic island, Nihima, should last at least several years, scientists say. So the top photo shows Nishinoshima Island, which is an uninhabited inlet in the Osogara chain, and a new island formed nearby as a result of undersea volcanic eruption, which initiated in November 21st, 2013. And then the bottom photo shows the same two islands in December 20th of 2013. So you can see that an extremely large amount of landmass can be added in a relatively short period of time, depending on the volcanic activity. Just to note, there were further eruptions in the year 2017, 2018, and 2019, with the latest eruption continuing as of March 2020, which has increased the island size to 2.89 kilometers square as of a measurement made in 2019, which is 1.12 square miles. So it's continuing to grow even now. I know we're almost 20 minutes in, and we haven't actually jumped into the lesson, but this is the last slide before we do, and I just wanted you to get a nice visual depiction of what are some of the potential climate change effects in the ecosystem and our organisms. So at the center of this, we have some of our most important facts that, depending on what's happening with the temperature, with the precipitation, and with the sea level, it's going to have extreme impacts on the following things. So first, forests, then coastal areas, agriculture, water resources, species in natural areas, as well as our health. Not just the health of human beings, but the health of other species as well. All right, so do you think that global warming is something that may happen in the future? Climate change is affecting the world right now. We know that. So ecosystems are changing, and the individual organisms are experiencing the effect of those changes. Climate change is also affected people, including how people make their living and even some people's health. Effects on ecosystem and the organism is where we're going to start with this. Think of the ways in which temperature and climate are important to ecosystems and individual organisms. For example, temperature and rainfall both affect animals' food supply. When the climate changes, the lives of organisms usually change too. The following examples demonstrate this. The first of which is the shifting of habitats. As ecosystems on land become warmer, the locations in which some organisms live are changing. The habitats of some plants and animals have shifted to places where the climate is cooler, towards the north and the south poles, or higher up on mountains. For example, in the Santa Rosa Mountains in California, the location of some plant species, such as the Jeffrey pine tree and the California lilac, have shifted upwards on average of about 65 meters, which is equivalent to 215 feet. So go ahead and look at figure 11. This is an example of the California lilacs that they're referring to in your textbook. And it's telling us here that in some places these lilacs are growing higher on mountainsides than they once did. There's another example there about robins. Robin is a type of bird, and robins arrive on the Colorado mountaintop about 2 weeks earlier than they did as recorded in 1970. The next effect on ecosystem and organism changes is the changing migration times. So just like we saw with the robin in the last slide, many species of birds migrate every year in the fall and spring. In the fall, they travel to places where the weather will be warmer and food will be more plentiful. Then in the spring, they fly back to their summer habitat. Some birds are now starting their spring migration earlier than before. Scientists infer that this change in migration is happening because the bird's winter habitat becomes warmer earlier than before. This change in temperature probably sends a signal to the birds to start their migration early. A change in migration time can cause problems for some birds. For example, in the spring, robins arrive on the mountaintop in Colorado about 2 weeks earlier than they did in the 1970s. However, climate change has caused increased snowfall on the mountains, so when the robins get there, snow still covers the ground, and the robins cannot feed until the snow melts. You'll also see a link here for some additional information if you'd like to see spring migration is now earlier in European and North American birds. This was a more updated article from February 25th of 2019, and it was written by a University of Helsinki. Another effect on the ecosystem and organisms is the ability to obtain food. So different species are having problems getting the right nutrients or completing the food chain like they normally would because of these changes. So migrating birds are not the only animals whose food supply is threatened by global warming. During the last few decades, temperature changes have been greatest in the Arctic. Ice sheets are melting and the sea ice is thinning. Ice-free areas are increasing in the Arctic Sea. The sea ice melts earlier and freezes later. It has become more difficult for polar bears to hunt the seals they feed on. Some polar bears have been dying of exhaustion and starvation as they try to swim long distances between the ice sheets. Because the number of polar bears is declining, in 2008 the polar bear was listed as a threatened species under the Endangered Species Act. So another difficulty and a side effect from the these animals in their natural environment not being able to obtain the food that they need, a lot of times hungry animals start searching more far and wide to obtain that nutrients that they need. And so I've posted in here an image and an article link if you want to read more about it, about hungry polar bears are found wandering into Russia industrial cities. So of course this is not only dangerous for humans that might come in contact with these hungry polar bears, but also this isn't the proper diet that they should be eating. So they're not going to be as healthy and as they should be either. So another effect on the ecosystem or organisms is the effects of the changing ocean. The ocean is becoming warmer. In addition, its chemistry is changing because it is absorbing more and more carbon dioxide. Both of these processes have begun to affect organisms in the sea, such as corals. Corals are tiny animals that use chemicals dissolved in water to build hard, stony coverings around themselves. When the animals die, the hard coverings remain. Over time, the stony coverings of millions of corals form a massive ocean structure called coral reefs. So you can see in our image here, the top image is going to be what the coral looks like when it is healthy and flourishing. And that color is coming from algae that's living on the coral. But then when the algae dies, you can see in the bottom image below that coral bleaching occurs. Coral reefs provide rich and varied habitats for many marine animals, such as sponges, worms, crabs, and fishes. Many fishes eaten by people, such as flounder, are part of coral reef food chains. Coral reefs protect beaches against waves and support the tourist industry. Today, coral reefs are dying worldwide, and this loss will affect both ocean biodiversity and the lives of people. There are many causes of coral reef destruction. Global climate change is just one probable cause. Warming water temperatures. Reef building corals contain microorganisms called algae within their tissues. During photosynthesis, the algae produce nutrients that supply energy, and the corals use some of that nutrients. Without these algae, corals cannot survive. However, in many places, the algae in corals are dying, a process called coral bleaching. Because without the algae, the corals lose their bright colors. Scientists do not fully understand why coral bleaching is happening, but evidence indicates that the problem is often related to unusually warm water temperatures. We're also contending with ocean acidity. Seawater absorbs much carbon dioxide from the atmosphere. As atmospheric carbon dioxide is increased, the amount of carbon dioxide dissolved in the ocean has increased as well. When carbon dioxide dissolves in water, it forms carbonic acid. The equation for the reaction is shown in your textbook. Over time, the addition of carbonic acid to ocean water has made the water slightly more acidic. Recall that the acidity of a solution is expressed as its pH. The higher the acidity, the lower the pH. The pH of the ocean water is slowly going down, and it will probably continue to do so as long as the ocean keeps absorbing more carbon dioxide. The increased acidity of ocean water may already be harming organisms that live in the ocean, including corals. Ocean acidity limits the ability of corals and other shell-building organisms to build their hard protective coverings. So what's the future of ecosystems? The future effects of climate change on ecosystems will be complex and are hard to predict. For example, an increase in atmospheric carbon dioxide may increase vegetation, since plants use carbon dioxide in photosynthesis. However, if drought and forest fires increase, plant life will be harmed and the plants may decrease in number. Changes will probably continue in the migration patterns of some animals and in the ranges in which specific species can survive, because they cannot survive in the changed environment. Some species can become extinct. Extinction of species will decrease biodiversity. So what is the impact on people right now? Extreme weather events such as severe droughts and heat waves are becoming more severe in some areas, and this increase may be linked to climate change. People are feeling the impact of bad weather and other problems associated with climate change. These effects will continue into the future. First, agriculture and forestry. The effects of climate change on our agriculture have been complex. Some crops, such as melons and sweet potatoes, do well in heat and have probably benefited from the longer growing seasons. Other crops, such as spinach and broccoli, are more suited to cooler conditions. In many areas, droughts have reduced crop yields. The forestry industry has also been damaged by extensive forest fires that result in part from longer, warmer, drier fire seasons. Also, forest managers are increasingly battling insect and disease outbreaks. Next, economic effects. When yields from agriculture and forestry decrease, people who work in those industries have a hard time earning a living. Huge storms such as Hurricane Katrina, which occurred in 2005, cause enormous damage, and this damage has economic consequences too. Businesses that cater to tourists, such as shops and restaurants, had to shut down because of Katrina, and therefore lost money that they might have earned. Homeowners, taxpayers, and utility consumers had to pay to have damages repaired, highways repaired, and power lines repaired. The financial consequences of storms is indicated by the amount of money that insurance companies pay to people and companies that have insured their property against weather-related damage. I'm going to share with you a graph from your textbook. Just give me a second. Okay, so out of your textbook, this is figure 14. So the graph in figure 14 shows how money paid to private and government insurers increased between 1980 and 2004. Rising insurance payments may indirectly indicate that storms are increasing in severity. So this just helps support the evidence that weather is continuing to worsen and cause more damage over time. Lastly, health effects. As atmospheric pressures have risen, the probability of severe heat waves also increases. Extreme heat can cause illnesses such as heat exhaustion and heat stroke. Heat stroke is a condition in which the body cannot control its temperature, and the body temperature rapidly rises. Heat stroke can cause death if it is not treated quickly. A 1995 heat wave killed at least 465 people in Chicago. In 2003, another severe heat wave in Europe killed about 35,000 people. So we've talked about what the effects are currently, but what are the future effects or impact on people? Computer modeling has enabled scientists to make predictions about climate change. The IPCC report indicates that carbon dioxide in the atmosphere will continue to rise, and so will the temperatures of the atmosphere and ocean. These trends will affect the way people live. First, disease. The ranges of animals that transmit diseases may expand as part of the world becomes warmer. Lyme disease, for example, is transmitted to humans by ticks. In Canada, Lyme disease is now confirmed in the southern part of the country. If northern Canada becomes warmer, the ticks may carry Lyme disease, might be able to survive in those areas, and the disease may spread northward. Sea level. As the oceans become warmer and polar ice keeps melting, sea level will continue to rise. People in the Maldives and other coastal areas worldwide are concerned of what will happen eventually in the United States. 53% of the population lives in coastal areas. Many people may need to find new places to live. And lastly, water supply. Rising sea levels increase the possibility that salt water from the ocean will intrude into freshwater aquifers and contaminate people's freshwater supplies. The disappearance of glaciers also threatens water supplies. When glaciers release melt water slowly, year after year, the meltwater feeds rivers and reservoirs. Therefore, glaciers now indirectly supply many people with water. If glaciers melt too quickly and eventually disappear, the water supply will no longer exist. In addition, dams on many rivers and reservoirs generate electricity. If the amount of water in those rivers and reservoirs decreases significantly, people would need to obtain electricity some other way. So let's quickly review the key concepts. As the atmosphere warms, ecosystems on land and in ocean are changing, affecting organisms in various ways. Next, global climate change is affecting aspects of human life, such as farming, forestry, the economy, and our health. And lastly, computer modeling predicts that climate change will continue to affect people. Stop and complete your assigned workbook questions before continuing to the answer key. I'm asking that you complete questions 1 through 15 in your workbook for chapter 16.3. Remember, guys, don't get too overwhelmed. If you go to answer the questions and you cannot complete them all, or you feel like your answer is not quite what they're asking, then feel free to use the answer key that I've provided on LMS, and I will actually scan through so you can pause and stop the video because I've listed them in this week's PowerPoint as well. So this is reading strategy for 16.3. And then I will just scroll through if you need to pause it at any point, or you can print the answer key from LMS. So this concludes our lecture and covering of chapter 16.3. Your assignment is going to be the lesson assessment at the end of 16.3, which has been assigned to you on the Pearson website. So go ahead, head over to Pearson, make sure that you complete the homework assignment, and I will see you guys tomorrow for the next lecture on 16.4, Responding to Climate Change.